Hey kids, it's Mr. Klein. Have you ever been in math and your teacher gives you two numbers and says find the LCM of the numbers or find the GCF of the numbers, and you're not sure what numbers you're exactly looking for because you can't remember the difference between LCM and GCF? Well, that used to happen to me when I was a student. I can see it happening to my students now, and I thought of a little strategy that might help you to remember the difference between them. So LCM, as you probably know, stands for least common multiple, and GCF stands for greatest common factor. Now, one of the reasons why they're confusing is because they both have the word common in them. And another reason, let me show you. LCM, for example, let's say you have to find the LCM of two numbers, 8 and 12. And so you know that, let's see, multiples are when you just add that same number to itself. Those are the multiples. So 8 and 16 and 24, 32, those are all multiples of 8. 12, we just add 12 to itself. 24, 36, 48. Well, we can see a common multiple, and that is 24. And we're looking for, so the least common multiple is the one that comes first. If we kept on going with 8, we would go to 40 and 48. We can see another multiple there, a common multiple. It's not the least common multiple, which is 24. I think one of the reasons why this gets confusing is because the word least makes us think that with 8 and 12, we should be looking for a number that is less than 8 and 12 because it says least in LCM, but we're actually looking for a number that's more than both of them. So what if we said this? Let's see, LCM, let's make that stand for list, we'll forget the C, list more. So LCM, with an LCM, you are listing more. Get two numbers, you just list more, that's your LCM. GCF, let's take 8 and 12 as well. If you have to find the GCF, the greatest common factor of those two common ways of doing that are making a little T-chart here, and we list the factors that when multiplied together give us the number we're working with. So with 8, 1 times 8 is 8, 2 times 4 is 8, and with 12, I'll scoot that over just a little bit. Let's try doing that with a factor tree, and 1 and 12 are factors. We won't list those, but we will list 2 and 6, and then we have 6, 2 and 3 are factors of 6. So we have 2 times 2 times 3, that equals 12. What's the greatest common factor of 8 and 12? Well, there's a 4 right here, and then there's a 2 times 2, which is also 4. And so the GCF of these two would be 4. How can we remember that? See, again, with greatest common factor, it's got the word greatest in there, and it makes us think that we're looking for a number that is greater than 8 and 12, but we're actually, the greatest common factor is going to be less than those two numbers. So what if we have GCF? We'll again take out the C, and we'll say that the G stands for ground, and the F stands for floor. Why? Well, because these numbers have factors that make up, you could say build up, they're like the foundation of each of those numbers, and we usually write them in the T-chart or in the factor tree beneath the numbers, and so they're like the ground floor numbers. LCM, list more, GCF, ground floor.